This morning I take my son to Robert Anderson, and of course there was a car that was disabled right there at the entrance. So, and nowadays, if you have a disabled car, meaning that, it won't crank or it can still move, you don't get out and push it out of the way. You don't do that because that would be common sense. What you do is you sit there and you just sit there. And then, people come up to you and ask if you need it. No, don't need no help. No, we don't need to push it out of the way. We'll just screw everybody else that's coming behind us. If your car is disabled and somebody comes up, 2 or 3 men come up to you and say, you need some help? Yeah, let's push this thing out of the way so these people behind us can get to work. Sorry, I had to say that because, I have several trailers that I carry feed and stuff on and livestock. One of my trailers broke down in front of Robert Anderson Middle School. Okay, so I drug it. The tire came off. Okay, the lugs broke because it was overloaded really, and I drug it with my truck for about 30 feet so I could get off the road so people could pass, so people could go by. Now, that you can't push a trailer with a truck. But when your car, like the battery's dead or you're out of gas, put it in neutral. The guys that want to help you, let them push you out of traffic. I'm sorry. Oh, and then, it gets even better. All right? So they call somebody to come, and what it was, the alternator was bad. How'd you know that, Hubert? Well, when your car cuts off and it won't crank back up, it's not the battery, okay? It's been running off the battery. Your alternator charges your battery, okay? If the battery runs down, your car is dead in the water, okay? That's why the alternator charges the battery to keep it charged up. So if your car dies and it won't crank back up, chances are the alternator's gone. Battery's still good, but the alternator's gone because the battery is run down. Kind of like the battery in a flashlight, okay? Take a solar panel, hook it up to the battery in the flashlight, and the battery stay good forever because they're rechargeable. See what I'm saying? That's the way it works. So that's what it was. And I told my son when we turned in, I said, their battery's dead. Well, by the time I dropped him off, I was sitting in traffic. This was like 5 till 8. I'm sitting in traffic at 5 till 8, right over here. And up comes whoever with the car, and of course, what do? They know that what's wrong because they pulled right up to the car and got the jumper cables out. The problem is, what's dead? The battery's dead. So you're going to have to sit there for about 5 or 6 minutes, and what? Again, there was 2 people in this car. These people could have pushed that car out of the way. Okay, I'm done. All right. Now, we're going to talk about, I was so mad at Kentucky. Kentucky should not have lost that game, but they didn't play worth crap. And oh my gosh, dadgum Florida, dadgum, outplayed LSU. That was the only 2 games worth watching. So I did watch those 2 games. Ohio State probably won. They probably played Burns High School. They don't matter. They're playing who? Who are they playing?
Indiana.
Oh, yeah. Indiana has been nowhere. Like I said, Burns High School. And that's a compliment to Burns High School, but it's an insult to whoever they were playing. All right. So that's my weekend. Watching 2 teams get beat that I didn't think it was going to get beat, but they got beat. So wasn't really. I drank a lot of beer this weekend. No, I'm just kidding. There's an inside joke to that, but I let's see, what day was it? Friday or Saturday? Saturday. I did drink 1 beer. It was a one of those water beers. What do you call them? Michelob Ultras. I drank one of those. And boy, it sure did taste good. I didn't even taste it. I drank it so fast. But It tasted good because of what it was for. I like beer. I really don't like beer, but I liked it that day. I think it was around 4 o'clock. Was it 4 o'clock? I think it was around 4 o'clock when he got confirmed. All right, so we're going to talk about today.
Oh, it hit me all at once. I got it.
Meanwhile, 15 minutes later, you don't have any idea what I'm talking about. I play football.
Once he said confirmed, I got it.
I play football. That's what we used to tell our. I had a math teacher at West Side, and he would make fun of the football players. And when we got one right, I play football. Anyway. Yeah. Anyway, we're going to talk about. We left off with Mayberry probability. And physical probability. Now, what did I leave off saying the Mayberry probability was? The perfect mathematical calculated probability. Theoretical. If I spell it right. Theoretical, calculated, mathematical probability. Meaning that you can tell me the probability of something happening and you don't even have it in your hand. Thus the deck of cards. Okay, you can tell me that the probability of a king is 4 out of 52, which is 1 out of 13. Correct? But you don't have a deck of cards in your hand.
I thought it was college the first year.
Then she got homesick. Okay, she didn't get homesick. She got tired of what? Riding up and down that road. There's an old saying, the road gets long. And that's very true. When you live in Charleston and you got to travel back and forth, it's very long. Anyway, she liked it, but she's going to now. I'll show her. All right, theoretical, calculated, mathematical.
You do it all the dang.
What? Dang old what?
When you do it all the dang time.
Yeah. She was coming home like every other week and then on holidays and stuff like that. And she just got tired of it.
I know the feeling.
It's kind of like in the Marine Corps. The first 2 years you're in the Marine Corps. Oh, that's great. Yeah, man. Got about 6 more to go in my enlistment. It's all real quick. So, all right, physical probability. Physical probability is the actual observation. Okay, so in a few minutes we're going to break up into about 4 or 5 groups, and we're going to do some actual observing. Now, let's take, for instance, the probability of tails on a coin. Well, y'all all know the probability of tails or heads is what? 0.5, which is 1/2, because of what? How many sides of a coin are there? There's 2 sides of a coin, and which one's heads or tails? 1. So that'd be 1/2. All right? Or 0.5. But if we actually did 10 times, if we flipped a coin, and we're not going to do that, but flip the coin 10 times, and it came up 3 tails, then the probability of tails would be what? 0.3. Now, they don't match. 0.3 does not equal 0.5. Therefore, we have the law of large numbers. Okay? And if you remember about last week, I said we'll go into the law of large numbers later. That's why we're going over it now. All right? And the best way to explain the law of large numbers, there was a couple of students in MIT. They had this written in the book, well, the Triola book, which was a good book, but at Tri-County Tech, if something's broke, if something ain't broke, you fix it anyway. And we decided to change books. But in this book, it had the story of these two students at MIT. And I don't know what kind of students they were. I don't know what major they were. I don't know if they were male or female. I don't know anything about that. But I know they were computer students because they wrote algorithms. And they took a roll of quarters and they infinitely measured how many quarters are in a roll. 40? Do y'all know what I'm talking about?
Yeah, I really do.
Okay.
I think it's,
All right, I wanted to make sure some people, I need to make sure they know what I'm talking about.
I think it's 20.
There's 40. There's $10, right? And there's 4 quarters and there's $1, that's 40. All right. So he took 40 of those, they took 40 of those quarters and they infinitely measured them. They measured them with a micrometer. That's to the 10,000th of a decimal point or whatever. They measured them, they scanned them with infrared or whatever, scanned them. They weighed them. They balanced them, checked to see if they were balanced. I don't know how they did all that, but they did all this measuring, about 5 or 6 different, and they did all 40 quarters. Okay? Then they took the average of those 40 quarters with the weight, the dimensions, the balance, buoyancy, whatever they measured about 5 or 6, and they took the averages, and they created an algorithmic quarter in the computer. Okay? And they wrote a program, and that program basically flipped the quarter. Everybody with me? So they wanted to see how many flips it would take to get that 0.3 over there to be 0.5. Does anybody want to take a guess how many flips it takes to get the Mayberry problem, to get the physical probability to equal the Mayberry probability? Anybody want to take a guess?
317.
You have no earthly idea what you're talking about. I'm just kidding. No, nowhere near it.
More.
Huh? A whole lot more.
Oh, really?
10.
Keep going.
10 million.
No, too many.
1 million.
Not too many. 100,000 flips. It took 100,000 flips, and the probability was 0.4999995. Now, why do I tell you this? 2 reasons. One, CYA. The other one is the large number rule. What is CYA? Cover your backside. If you are let's say that you're 15, 20 years from now, you're an executive with blah, blah, blah corporation, and you are the quality assurance director. What's quality assurance?
You're making sure the quality.
Making sure the quality of the product is 100%. You with me? And making sure nobody's getting killed in the factory while you're doing it. Everybody with me? Kind of a mix between quality assurance and safety. They're both having to do with each other. Okay. And let's say you're working at the Crystal Palace up there in Spartan, above Greenville towards Spartanburg. Let's say you're a Michelin director. Okay. And your job is to make sure that the Sandy Springs plant, the Anderson plant, Star. It's not Star. But anyway, we won't go there. Anderson plant, the Greenville plant, and any other plants that's in the southeast. I don't know of any others in the southeast except those 3 that are making good quality tire products. So you got to make sure you present to the board how much is budgeted, how much you think should be expecting to be bad tires next year. So the director, so the whole executive committee can create a number for next year's budget. Everybody with me? For bad tires. You have to send the tires back, they have to get melted. Okay? They have to get melted down and they have to get recreated or whatever. All right. So you decide, well, I got to go to this. I'm just going to go over to the Sandy Springs plant and I'm just going to pull 15 tires. Okay? You pull 15 tires and 5 of them are bad. So you say, okay, that's 33%. So I'm going to base my report on 33%. So you present to the board or the directors or whatever, and they say, okay, 33% of our population of the Southeast, that comes up to be $1.5 million in bad tires. So we're going to budget $1.5 million next year for bad tires. Everybody with me? Next year comes around. And instead of it being 33%, it's 72% or 56% or 48%, which comes out to be a difference of $1 to $2 to $3 million. What are you? Good job. Wow. I didn't expect that. I expected a look of dumb, dumb look. I'm very proud. You get fired. Why? Because all you're paid to do is what? Crunch numbers. And you only pulled 15 tires. You had a little bit of LAD, lazy attitude disorder. Okay? When you pull statistics or when you pull probability, you better CYA and use what? The law of large numbers. Instead of 15, that person should have pulled 1,500 or 15,000. See what I'm saying? Got to cover your rear end. If you're going to give a report, if you're going to give any kind of information to your boss, we're not talking about at McDonald's or Pick and Pay or what's the place up here that sells shoes? Shoe Carnival or whatever. Wherever you work in high school is not what I'm talking about. I'm talking about 10 or 15 years from now when you're an executive or you're blah, 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 blah with blah, 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 blah company. And somebody says, I want to see a report. Report. Remember, report, CYA, law of large numbers. You better make sure you cover your what? Your backside. You better make sure you do some research. If you're supposed to give a presentation and it goes into a budget for next year, you better make sure you have the numbers. And that's what the law of large numbers do. Law of large numbers is not only in statistics, but it's in what? Probability. And with probability, the closer you are to that the theoretical probability, the better. Capiche? All right. So let's talk about some Mayberry probabilities. And we're going to go over these before we do the in-class project. Probability of a king. Okay? Now, the probability of a king, y'all all know. Hold on a minute, that might be. I was making sure that somebody didn't want to. Okay. We'll make sure that Miss Johnson didn't get cut off. Miss Johnson, you still there?
Yes.
Okay, yeah, she was too busy sleeping, I'm sorry. She's probably laying in bed sleeping. But anyway, probability of a king. There's 4 kings in a deck of cards. If you don't know that there's 4 kings in a deck of cards, what is my suggestion to you? Go get your butt a deck of cards because they're going to be on standardized tests and they're going to be on this test. And if you really don't know that there's 4 kings in a deck of cards, you don't tell anybody, okay? You just quietly go to Walgreens and get you a deck of cards, put it in your pocket, take it home, and figure it out yourself, okay? But you do not announce that you don't know there's 4 kings in the deck of cards. All right? So that would be 4 out of what? 4 out of 52. Again, there's 52 cards. What about the jokers? That would be 54. There's 2 jokers. They put them to the side. Put the instruction card to the side. That's not a card. And put the card with the company logo on it. There's 4 cards that you just put to the side. Everybody with me? For those that's going to go buy some cards, okay? All right, 4 over 52, which reduces down to 1 over 13. Okay, simple enough. But what if I say, what about the probability of a face card? Well, now you got to start thinking. Let's see, there's a jack, a king, and a queen. That's 3, and there's 4 suits. So that's 3 times 4 is 12. So instead of 4 over 52, it's what? 12 over 52. Now from here on out, you do the calculator. I'm not going to reduce. You reduce. You put it in a decimal form. I'm not going to do that. We're just learning how to pull, because I could easily say, what is the probability of a heart? What is the probability of a heart? Well, how many hearts are there? 13. There's 13 in each suit. See, this is why some of you that don't announce that you don't know a deck of cards, you go get a deck of cards. Okay? And you learn that deck of cards, because I'm going to tell you right now, there's 3 things that they ask on standardized tests. Cards, beans and peas, and babies. Those 3 things. Okay? Beans or peas. That's those things that you eat. Okay? The yellow pea versus a green pea. Protein comes from yellow peas. Do you know that? All right. Equals what? 13 over 52. I think that reduces down to 1/4, which is 0.25. I saw that. Mountain Dew. It comes in bottles that are green. Yeah. Ew. Whatever. All right. So, what is the probability? Here we go. You're going to have to think on this one. What is the probability of an even card? Oh, wait a minute. I can't do that. I don't even know how many even cards there are. Get a deck of cards. 2, 4, 6, 8, 10. There's 5 number cards that are even. Write that down. And then what else is even? The face cards are even. So that's a face card of 3. So how many are even in a deck of cards? 8. But 8 times 4 suits is what? 32. 32 over 52. Now, we're not only going to talk about the theoretical probability, but we're going to talk about odds here and the complement in just a minute. Who's got a question? Any questions? All right, now we're going to take it over to a die. Number 1 missed question on a test. What is the probability of rolling a 7 on a die? 30 people I gave that to. 5 people got it wrong. Because we had live PD. Y'all ever seen live PD? You need to watch it. 0%. 0%. Why? Somebody tell me why you can't roll a 7 on a die. Because it's not on there. Okay? What is the probability of rolling an even number? Well, what numbers are on a die? Well, let's see. There's 1, 2, 3, 4, 5, 6, because there's 6 sides to a cube. Did y'all know that? All right, 1, 2, 3, 4, 5, 6. 2, 4, 6. 3 out of 6, which is 0.5. I'm just going to write 3 out of 6 because I know all of y'all can reduce. That's not what I'm here teaching you. I'm here teaching you how to get the probability. Everybody should reduce. 100% reduce whenever you can. The answer is 1/2 or 0.5. What dictates whether you write it as a decimal or a fraction? The directions. Okay, the directions. They'll tell you. What is the probability of rolling a 2? 1 out of 6. The probability of rolling any number on a die is going to be 1/6 because there's 6 numbers. There's 1 number each. There's 6 sides. Now, the reason I'm doing this, and the reason that most of y'all are going, it's boring. You've already seen this, but I'm not teaching the people that's seen it. I'm not teaching to those that invented statistics or probability. I'm teaching to those that haven't taken it. So I'm starting from the get-go. Same thing with babies. All right? What is the probability of having a boy? 0.5. What is the probability of having a girl? 0.5. I don't give a damn what political correctness says. All right? As far as I'm concerned, there's 2 genders. Now, what's up in here, that's something else, okay? But I know for a fact that there's only 2 genders. If you can figure out a way that somebody's not born without one of those 2 things, let me know, okay? Now, there is possibility of 0.01% of 0.01% being born without those 2 indicators. But those 2 indicators are usually there. So, we're going to go from a non-political correct standpoint of those two indicators. And everybody, somebody explain to him what the two indicators are, all right? Because you know what they are? Okay, good. Eyes and ears, right? All right, so we're going to go from that political standpoint, that two indicators. So the probability of having a girl is 0.5. Probability of having a boy is 0.5. Now, you will see in homework questions and other questions when we get to the binomial distribution and all that good stuff, that they changed the 0.5 to 0.57 because of reproductive experimentation and research, okay? But they're just making those numbers up, okay? If you make it 0.5 all the time, then you can't think of the probability distribution, and I'll get back to that when we get to it, but we're not there yet, okay? So, with a baby with a baby is 0.5 and 0.5, that's pretty simple. With a deck of cards, you got to know a deck of cards. With a die, you've got to use a little bit of common sense. All right, now, what is the complement? The complement is what makes up the whole. That's a Hubertism definition. The complement is what makes up the whole. Now I'm going to put whole in quotation marks because I'm not meaning one. Okay? The whole means the class. If I got 15 women in here, okay, how many men are in here if there's 30 students? That's the complement. All right? If I have 4 women in here, then what's the complement if the class has 30? 26. The complement, it doesn't have to be male or female. It can be just I have 4 blanks. What's the complement? Be 26. All right? What's the whole? 30. The whole can be 1. It can be 100. It can be 30. It can be 35. It can be 25. N is always your whole. N most of the time is your whole. If 250 people were surveyed and 150 of those 250 were female, then what's the complement? 100 males. Okay, it's always what makes up the whole. I like to tell people, when I was going to Southwood in the hood, when I was going to Southwood, lunch cost 65 cents. Okay? My mother and father would give me $1 every day. Okay? They would give me $1, and of course, I would buy my lunch and I would have 35 cents. Okay? The complement of that $1 is 35 cents to my 65 that I paid for lunch. Okay? Well, that's what you're going to see. This is what you're going to see in probability, because probability goes from 0 to what? 1. So you got to remember that with probability, with area under a curve or with probability in general. If I say the probability of blah, blah, blah is equal to 0.6, you're going to tell me the complement is 0.4. But other than the complement, you have the complement where n is equal to some number. N is equal to 250. If there's 150 females, then the complement is 100 males, because the whole is 250. The whole is always n, especially with a group or a population or a sample. Okay, so that's the complement. So there's 2 different kinds of complements. There's the complement of probability, which is equal to 1, and then there's the complement of the group, or n. Okay, so that's going over the complement. Now let's go over odds. And I'm going to tie all this together when we do our in-class, when we do our in-class okay? The odds against is equal to the probability of success over the probability of failure. Probability of success over the probability of failure. Now, when you're doing these problems, you want to keep your probabilities in terms of fractions. Why? Anybody know from probability in high school? Why do you want to keep them as fractions? Because what do you do when you divide by a fraction? That's what I heard. What if I talk like that? I'm going to start teaching like that, like y'all mumble and whisper. I'm going to start teaching like that. Would that piss y'all off? Huh? What's that?
Mr. McClure.
Yes. You going to talk to me?
Screen.
The one that's not in the classroom talks to me. Miss Johnson, yes, ma'am.
Can you share your screen? I can't see anything.
I thought I did share it.
No.
Yes, I did. I know I did. Because I had that presentation on top of it. Look here. Well, it must have quit. What?
I felt like that was in her live stream again. Why is she smiling?
What school do you go to? I'm going to call your principal. I probably know one of them. And I'm going to tell him you need to be sent back. Oh, like my son. Oh, gosh. Me and my son had it this morning. Can you see the screen now, Miss Johnson?
Yes.
Okay. It must have cut off because I did turn it on. It must have cut off. I don't know. All right. So now I don't figure out what I was doing. Oh, yeah, I had a fight with my son this morning. Not a fight, but an argument. I'm trying to teach him, well, there's a lot of things. Oh, forget it. Just forget it. Anyway, common sense, critical thinking. You know, they don't teach that in school because they just want y'all to be dumb, ignorant people so they can control you. But the critical thinking skills and the communication, something else. Y'all don't communicate. I got 2 or 3 classes. I'm doing polycom, and they just sit there like this. It's like Patrick with the orb of confusion. And then they get mad because they don't understand what I'm going over. What do you do if you don't understand?
Ask questions.
You know what? You know the number one thing to get fired when you're in a job is not what? Not communicating. So, for those people that want to keep their head in the sand, you might as well just get you a job as a mathematician actuary so you can sit in a closet all day, because that's about the only job where you don't have to communicate, is you sit in a closet all day and you calculate for insurance companies. Okay? That's what you need to be doing. Other than that, you need to learn how to communicate, like Miss Johnson did. Only it was like half the class. She finally said she couldn't see the screen. But I think it turned off, Miss Johnson. Anyway, because I think, were you able to see it at the beginning of the class? Miss Johnson?
Yeah, I was.
Yeah, it turned off. I don't know what makes it turn off like that. Okay, so the odds against, or the probability of success, probability of failure. What do you think the odds in favor are? Probability of failure over the probability of success. It's the reciprocal. Write that down. The odds in favor is the reciprocal of the odds against. And why do I do the odds against? Because that's what you're going to be asked on a test, on a standardized test, and in real life if you have anything to do with gambling. Okay? So, success is determined by the question. Success is determined by the question. What do you mean, Hubert? Well, if I ask you, what is the probability of, you're playing at a gambling table in Las Vegas and a face card wins, what is the probability of winning, blah, 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 blah. Well, what is winning? What is success? The probability of you pulling a face card. So the probability of face card is success. The complement would be the probability of not pulling the face card, which would be the complement of pulling a face card. Everybody with me? Just like we were talking about a while ago. So, if I tell you that you can win money by pulling a face card, then the face card is going to be the probability of success, and the probability of failure is going to be not pulling a face card, which is the complement. So your complement is going to fall in this, and the bottom, or whatever. So the probability of a face card is, what did we say? 4 out of what? 52. What's the probability of not a face card? 48 out of 52. What?
Did we say the probability? Yeah. Did we say the probability of a face card was 12 out of 52?
Oh, you're right. Thank you. You're right. I'm thinking of the king. Sorry. Well, let's deal with the king. Let's just go with the king. Let's just change this to a king and not a king. Okay, the probability of the king and the probability of not a king. Now, does that mean not a king when you see an X through a K? Yes. Sometimes you see probability do that. The probability teachers, statisticians, sometimes you see books do it. The complement is always either going to have an X on it or it's going to have a what? A line on top of it. So make that note. All right, so anyway, so we multiply. This is why you keep everything as a fraction, because this is going to be 0.52 over 4, and 48. And what happens to the 52s? And I just got something mixed up. I'm sorry. I did the probability of success. Probability of failure. I'm sorry. Just mark through that, y'all. It's the probability of failure over the probability of success. Probability of failure. I don't need anybody to say, "Oh, hold that." Shut up. Probability of success. Okay, I had it math backwards. Probability of failure over the probability of success. So let's redo that. What is the probability of not getting a face card? 48 over what? 52. And what is the probability of getting a face card? 4 out of 52. And multiply by 52 over 4. And the 52's cancel. And you're left with 48 over 4, which is what? 12, Hubert. So you have 12 to 1 odds. So if you bet $1,000 on this card game, what are you going to walk away with? $12,000. You multiply the 12 times 1,000. But you got to have a face card, a king. You got to get a king. Now, let's talk about this, because it's very important that you see this relationship. This goes in that critical thinking box that I'm telling you, a little bit of common sense and critical thinking. Okay, and we're going to talk about the most famous saying that's ever been taught to me in my lifetime. Nothing is what?
Free.
Free. Nothing is free. Okay? Is Las Vegas what? Is Las Vegas prone to be in the donation business? What are they? They want to take all the money you got. All right? They're not in the philanthropy business. So if you walk into a casino, put in your brain that they want to take my money. Okay? How do you know that? Well, what is the probability? And highlight this number right here. And somebody crank that into your calculator. I know it's 1 over 13, but what is the probability? Well, it's 1 over 13. Somebody do it for me right quick. Those boost. See those boost right there? How much sugar's in that boost?
We are doing
Oh, we are the. I'd say 47 grams.
47 grams.
47. How much? Okay, they cut down. Its juice is 47 grams. That's it.
48.
What is it?
20.
20. Okay, not as much. Only a third, half of a third a cup, which is sixth of a cup of sugar. It's not too bad.
Donut is 10.
Huh?
Krispy Kreme donut is 10.
Yeah. So that's equal to 2 Krispy Kreme donuts. And what's worse, a third a cup of sugar is in a health thing of juice, an 8-ounce thing of juice, 47 grams, which is 45 to 47 grams, which is a third cup of sugar.
And they tell us to that.
But they're healthy. Yeah, you're being healthy. All right, 12. You always multiply that. Now, What is the 1 over 13? What'd you get? You know, there's a calculator on y'all's phone. What?
0.07.
0.07. Okay, so 1 out of 13 is 0.07. Somebody tell me how close that is to 0. Okay, the lower the probability, the higher the payoff. Write that down. How many of you have gone to Las Vegas and seen the nickel slot machines? Okay. All the people over there like tearing it up. They just over there throwing them nickels in. Okay? What's the chances of them winning? They're going to win. Why? Because the probability is high. They're going to win a little bit, but they're not going to win a lot. But if you take and you put a $20 bill in a slot machine and you hit it, then you're going to win what? A lot of money, because the probability is very low. Okay? Remember this. There's two things that are not in the philanthropy business. The bank and Las Vegas. Okay? They're wanting to make money. They are not in. So, if you have something that comes up with a low probability, the odds against are going to be very what? High. Let's take, for instance, well, we'll do that later with factorials, but let's say that, let's do a roulette table. That's a good probability question. A roulette table is I ain't going to pull it up, but it's got the slots like this, and you spin the table, and what goes in the opposite direction? Dang old marble. And that marble goes this way, and the wheel's going this way, and what happens? The marble falls in one of the slots. Everybody with me? Now, there's two slots that you may not know about. Two slots, and put them in green because they're usually in green. And that is 0 and what? Double 0. The rest are 1 through 48. We'll do 1 through 48. Okay, so 1 right here and 48 right here. Everybody with me? So I'll do this because some of y'all might be confused. 3, 4, and then 47, 46, 47, and then everything's between. All right? That's why I had to write those 3 numbers down. What? Okay, now the question's going to ask you this. What is the probability of the marble falling on an even number? But they're going to tell you that these two numbers are neither, I don't know how to spell neither odd or what? Even. And that's the kicker right there. Okay? So you got to find the complement of even to not even. What's the opposite of guilty? Innocent. Innocent. Good. Is OJ innocent or not guilty? He's not guilty because he's not innocent. Okay? Let me explain to you. I'm going to explain to you about those two things because a lot of people get kind of crazy on this. Let's say that Miss Kathy works at Papa John's Pizza. Okay? And she works there, and she's been there for like 20 years, and she's wanting to make a career out of delivering pizzas. All right? Now, she wants to fuss at the federal government for not making her wage at $15 an hour, even though she didn't make a good decision to go to college and make a career out of something else. But she's wanting to make $15 an hour and raise 15 kids on $15 an hour. All right. Now, let's go with Miss Johnson. Is Miss Kathy's roommate. And Miss Johnson is like the manager, and she's, real good manager, and she's very responsible, but they are roommates, okay? Or they share a house or whatever the case may be. And Miss Kathy, well, she wants to have 15 kids, okay? But anyway, Miss Kathy decides that she wants to rob a bank. Okay? But she ain't got no car. Alright? She ain't got no car, but Miss Johnson has a car. So Miss Johnson's at work, and the loser, Miss Kathy, decides that she wants to borrow her car. So she borrows her car. All right? She borrows her car. Meanwhile, Miss Johnson is at work at Pizza Hut, slaving herself, make money. What?
How did she get to work?
Huh?
How'd she
I
get to
thought
work?
it was
Bus.
She, huh? They usually ride together.
She Ubered.
They both work at Papa John's.
So we're going to try it all.
Okay, why are you asking questions that are not relevant? Okay, you're going to fail. All right, you're going to fail. All right, so Miss Kathy goes and gets the car, and it's about 5 o'clock in the afternoon. Miss Johnson's been there. She got there at 2 o'clock. Okay, she took the bus. Thank you. She took the bus to get the car. Okay. All right, everybody's got a lot good timeline here. Okay, so Miss Kathy goes and gets the car. She goes to the bank, hooks a chain up to the ATM, and pulls the chain out and runs down the road with it. Okay. Now y'all know this is all fabrication. Okay, I'm not trying to say either one of them would rob a bank or anything. I gotta say that because somebody will say I'm offended. All right. So anyway, Miss Johnson breaks open, takes her torch and her acetylene torch, and she breaks open the safe, and she takes the money out, and she throws the safe in the river, and takes the car back to Papa John's, and everybody's happy.
I thought that
Okay.
Brooklyn was the one.
No, I thought it was Brooklyn that wrong good.
What?
Why is
I'm sorry, Miss Kathy did all this. Miss Johnson's at work. Okay. The reason this is not working right is because Miss Johnson's not sitting in front of me. She's in the projector up there. So Miss Kathy is at home. She's watching a movie, eating pizza, and she's got a pocket full of money. All right. Meanwhile, what's happening back at Papa John's? Popo come back. Okay. And basically trying to take Miss Johnson away. Okay? Will Miss Johnson ever go to court? No, she will not. Why? Because she's innocent. How does she know? How do we know? Well, what does Papa John's have all in it? Cameras. And how many people work at Papa John's to make one pizza? 15 people. Okay? So, all right? So, you've got cameras that see Miss Johnson working. You've got eyewitnesses that see Miss Johnson working. She will never see court because she is 100% innocent. Okay? Why did why wasn't he innocent?
Because the glove didn't fit.
Because he did not have a what?
Alibi.
He didn't have an alibi. Nobody could place him anywhere. Okay? Sign, hang a sign around your neck, don't talk. Okay. I need you to meet my son. You and him would hit it off just right. Okay. The whole point of this story is Miss Johnson is a winner and Miss Kathy goes to jail. Okay? No. Thank you for participating. But anyway, the whole point is she is innocent. Innocent is not the same as guilty. You're not going to see an innocent person go to court. The only person that goes to court is somebody that can't prove they're what? They're innocent. They can't prove by cameras or whatever that they wasn't there. Not to mention the bank camera that's got Miss Kathy smiling while she's putting the log chain around the ATM. Okay? So now we know the difference. Yeah, duck face. Yeah. I never will understand that. Hey guys, you gotta watch out. Okay? How many guys been? 3 or 4? You got to watch out. These women with these filters and these things that they put on there. Oh my gosh! I ain't gonna say who it was. Somebody came up to me and said, "I got something to show you." And I went on a date the other night, and I said, "Did you?" He said, "Yeah." I want you to look at this picture. He showed me the picture. Oh my gosh! Looked like a freaking 10 and a half. You know what I saw? He pulled up the other picture. I went. I said, "Is that the same person?" Yeah. Oh my gosh. Totally different. Totally different. Dang old, do not go out with a person unless you meet the person. Because these women, they're being fraudulent with these daggum filters and you got to watch all these women in here. Yeah, these women in here. I'm just kidding. This is a joke, but you got to watch it. I don't know. Men don't know how to use filters, so I don't know. I don't think it'll take them a while, maybe in 10 years. But anyway, there's a difference between the complement of guilty, not guilty, and innocent. Innocent's really not in there, okay? Because innocent never will go to court. All right? Now, you have to prove you're innocent, and that's something we've been talking about here in the last couple of weeks. The United States is known for proving you're what? Guilty. You don't have to prove your innocence. You're innocent. Up until the last couple of weeks, you're innocent until proven what? Guilty. And that camera, thank goodness for what do they call them now? Body cams on the policemen. Watch dang old live PD. See what policemen have to really deal with. Oh gosh, I love watching drunk people get tased. I love that. Okay. There was one on Facebook the other day where a guy was stealing a tractor.
Brooklyn.
Okay, are we clear? We're not stealing an Acura or an Infinity. We're stealing a tractor. So he gets off the tractor, talks with the guy, the policeman, and the policeman starts to lock him up because one, he's drunk, and two, he's stealing somebody's tractor.
Wait, wasn't he like driving down the road with them?
Yeah. The guy takes off running. Okay, this guy's drunk. He's in the Marlboro Club, so he can't run 50 feet. All right? He takes off running down the road. The guy tases him. He falls face first into the pavement. The funniest thing I ever saw. I watched it like 10 times. I love watching people get tased. But anyway, I don't know where I was going there, but now I like bacon. Anyway, probability of even would be 24 over what? 50. Okay? So what is the probability of not even? The probability of not even would be 26. All right, now I want you to figure the odds against winning. And then I want you to bet a $500 bet. So the odds against winning is the probability of failure over the probability of what? Success multiplied by 50 over 24. And 26 over 24 is 13 to 12. So that's 1 and 1/12. Somebody give me that decimal. What's 13 divided by 12?
1.08.
1.08. So multiply 500 times 1.08. $500 bet. 1.08 times 500. 541. So you take home $41. Well, why is that? Because now, what if the number was to fall? You win if it falls on 2. Do that one. Probability of a 2. Somebody tell me what the probability is going to be. Very high or very low? Very low. So if you bet 500 on this one and you hit a 2, you're going to win a lot of money. So probability of 2 is 1 over what? 50. So therefore the probability of not a 2 is what? 49 over 50, which basically gives you 49 to 1. And somebody tell me what 49 times 500 is. That's a pretty good payday, isn't it? But that's why the probability is so low. That's why nothing is free. If you walk into a gambling situation and they say the probability is 0.5, you ain't going to win crap. But if they tell you that the probability is 0.05, then you make a bet. But you got to have money to burn if you're going to make a bet. All right. We didn't get to the cards. We'll get to the cards next time because some of y'all go into cardio infarction. Anyway, y'all have a good day. Y'all can work on now chapter 5. Chapter 5.1, I think. No, I hadn't fixed anything. I'm lazy. Well, tell me.